Hi everyone, welcome to Advanced Model Selection. We are covering here Langchain version 1 agents. We have already covered 3 videos where we have discussed how you can create a basic agent, then how you can create agent with separate model instance so that you can set model parameters. And in the previous lesson, we have seen how you can select dynamic model, or basically how you can select the models dynamically. So we are covering here Langchain version 1 agents videos here, all the changes which Langchain version 1 is bringing. And if you watch here my channel, so at the channel, we already have a playlist named as Langchain version 1 agents. And also the Langchain version 1 projects are also available there. And the code for this particular lesson and for all the upcoming lessons are already available at my GitHub repository, Lakshmi Merit Langchain version 1 agents. The link of this playlist and the link of this particular repository and other repositories where I have discussed about the Langchain version 1 projects, all these are given in the video description. You need to come here in the code notebook. Inside the code notebook, you will see all the notebooks which I'm gonna cover and whatever I have already covered. Having said that, let's come back what we are discussing here. So this is something which we have been discussing since last 3 videos in this particular playlist. That agent is made up of LLM, prompt, and the tool. And in the previous lesson, we had seen how you can select model dynamically if you pass a query, and then how your code is deciding which particular model it need to select for a particular query. So that we selected with the number of the messages basically. So if you have less than 10 messages, then it is going to select the Queen 3 model that is in the previous video. And if it is greater than or more than 10 messages, then it used to select the GPT-oss. But in this particular lesson, I'm gonna show you how you can make it more advanced. So basically, just instead of total number of messages, how you can make it the context aware, or you can say the query aware. If you have some complex query, then dynamically it can select a larger model and more capable model. Otherwise, for simpler query, it can select the simple model. If you have heard about the GPT-5, so GPT-5 has brought one feature where it says that it simplifies the chat GPT to single auto switching system that brings together the best of our previous model into smart and the fast model. So basically what they are talking about here from the OpenAI, they are saying that they have a system, something like this, where a query comes, then thereafter they have a model selection system. Based on the query complexity, model automatically gets selected, whether more performative model need to be selected or a simpler model. All these are decided in the OpenAI itself. So similar to that, on that particular line, we are going to see here that how you can also make your own code so smart that it can automatically select the best model for your use cases. For example, if total number of character goes beyond 3000, otherwise, if it contains some complex keywords, or the total message count goes less than greater than 8 or 10, whatever you decide. So earlier we used only the message count. Now we are going to see the total characters, along with that some complex keyword. Like let's say you have some detailed data analysis or something like that. For that time, you need a larger model. Having said that, let's go ahead and see how this overall implementation is going to be here. So I import chat Ollama. As you already know that we are using the Ollama here. So in the Ollama, we'll be using our GPT-oss and the Queen 3 model. Again, if you're not aware about the project setup and all these things, you can come here in the project setup.md. I have already explained everything, how you can do all these things. Other than the Queen 3, let me just write here the Ollama full GPT-oss as well. All right, so the 20 billion model, 20 billion parameter model will be also pulled, and then you can start serving the Ollama. Otherwise, you can just install Ollama and run the graphical Ollama. Again, for that particular Ollama video coverage, I already have here a playlist, local LLM. There I have covered that what are the basic setups which you have to do for the Ollama. Okay, so all the necessary libraries we have imported here. The two important things you will notice, we have our create agent and the agent state. So this create agent is going to create agent, and this agent state is going to maintain the state, or you can say the messages which is going through the agent here. Let's go ahead and execute this. Once we execute, it is going to execute like that. All right. Let's go ahead and write our method which can intelligently select a particular model as we had discussed previously. So first of all, I create a standard Python method which I write intelligent model select. It is gonna take state here. So state type is going to be the agent state. Let me again tell you, as I have been telling you previously, how the agent state is gonna work. So basically what happened here, whatever the information you pass as a query, that gets stored into the state. All right, then that state flows to the LLM, and then that state again gets passed to the tools as well. Let's say your query comes into the state, it has one messages here basically, but as soon as it comes through the LLM is going to have the two messages here. And then in that state, it comes to the tool. After executing the tool, it is going to have a three messages. Then again, that state gets returned with all these three messages. Then this time state is going to have here the four messages, and so on. As it repeats here, the total number of messages gets added to the state. So with this, you will notice here that state is going to have all the messages. First, second, third, and fourth, all those messages are going to be included into the state. So it has the history as well. If you see here in this way, that whatever the human message comes here, then the AI message, tool message, then again AI message, and the consecutive messages, all those are going to be maintained into the state itself. So state you can consider as the historical messages as well. All right. And if you see the output, if you just want to understand, this is how it is going to happen here. So basically, let me just show you here. I'm just going to quickly delete these one by one, and then I'll explain you how these overall things are going to happen here. So first user query comes into the state. So this whole thing, what you see, this is going to be the state. In the state, you have a messages there, and messages are actually the list type. So the first human message come where you have some kind of the search query or something like that. Whatever you have there, that becomes the human message. After the human message, then AI execute this human message. As you saw here, that once user query comes, all right, so that is the S1, then LLM execute that, then that becomes here, I mean, state is having here the two messages. So as you come there, all right, so as you come there, it now have a two messages basically. So now you will notice state is having two messages. After the AI execution, it says that I need to call a tool. Then it calls a tool. Now your state is going to have a three messages. And if you see this state as a whole, in that you will notice that your state is also maintaining historical messages as well. And thereafter, this tool message goes into the LLM, and LLM is going to have all these historical messages here. And then you have here all these AI messages. All right. So now you will notice all these four messages are going to become a state, and all these are going to have all the historical messages. All right. Perfect. So this is how it is going to work. That's what I have done here. So state is going to maintain all the messages. And with this, we can get the total length of the messages here. So if you take the length of this particular list, with this, you can see how many messages are there particularly. Okay, so we get the total message count. Along with that, now what we can do, we can go over each messages. All right, so we can go over each messages. So for MSG in messages, so basically I'm going over each messages. This message, this message, this. And in each message, you will notice there is the content. So this content is going to have the LLM response or the tool response. So the content is, it's going to first have a human query or the user query. Then AI message content is going to have the AI message, and then the tool message content is going to have the tool messages. And thereafter, again, AI message content is going to have here again the AI message, AI response. All right. So what I do here, I iterate over the messages. For each message, I read the content and then get the length of that content, and then I sum everything together so that I can see here total how many characters are there. Before doing this part, I'm also checking here that there has to be a content in the message. So let's say if there is some empty message or some error message where it is having something like let's say something like this, then in that case it is not going to read. Otherwise, if you read that, then it will throw the error. Just to avoid that particular part, I have provided here a conditional statement where it dynamically checks that content is present there in the message. Perfect. Thereafter, what I do here, I have written here some complex keyword as well. All right. So let's say if I ask some kind of the analysis, some kind of the research, detailed analysis, comprehensive research, complex strategy, etc. So you see there, these are the complex keyword. So this is something which I have done manually, but if you go in the production, obviously you can make a large list or you can dynamically decide by the LLM itself, complex keywords. Okay. So just for the simplicity and just show you the strategy, how you can make this intelligent model. So I have selected here one of the simplest form. So this is how you can select the complex keyword. Thereafter, you can decide that is there any of these complex keywords are present in the human message. So human message is going to be the first message in your state message. All right. So what I do here, first of all, in fact, instead of the first message, so I go over all the messages here. So I iterate over all the messages, and then in all messages, I'm checking that if any of these things are there. All right. And then finally, we iterate over this complex keyword, and then we finally check that message need to have content. All right. Otherwise, it is through the error. So that conditional statement makes sure that it has the content. Thereafter, the multi-factor decision logic we have here. So the two logic we already have here. This is the same logic which we had. This one is like the character count based. This one is based on the complexity of the keyword, and this total length is going to be the compared here. So total length goes more than 3,000, or the message count goes more than 8, or it is going to have some complex. So any of these things, if happens, then it is going to select the GPT-oss with the temperature 00, number of predicts 2,500. So it is going to maximally predict 2,500 tokens. So this is something which we have already seen previously here in the agent model instance. We had used their various parameter to test our model instances. Thereafter, in the else statement, we have a Queen3 message count, total message length, has complex count. The chat Ollama is here. That is the chat Ollama model instance, or you can say the model instance. So in this case, we are selecting one of the simplest model, that is going to be the Queen3 model. That's all we have here. And then we have our agent is equal to the create agent. Then we have our intelligent model selection. Then we have our tool. So this is the standard way to select the model. All right. Perfect. Let's go ahead. Okay. Let's go ahead and execute this. So I just simply run this. Now you will notice your agent is created here. So one more thing you will notice here, that you might think that it is redundant, but I had shown this intentionally so that you can understand. Suppose that you have a various model instance. In particular model, you want to bind tool, all right, which you don't want to bind with the Queen3. So in that case, what you can do, you can provide the tool which is specific to that particular LLM only. So something like this you can do. And here you also see the tools there. So you can also provide a tool which is going to be used for all the LLMs, whatever LLM we have here. So how this is going to work, whatever tool you have provided here in this particular LLM, and plus whatever tool you have this. All right, it is going to select only unique tools. So we have same tool here and here. So it's going to select only one tool in the agent. But hypothetically assume here, let's say in the GPT-oss, if you have provided additional tools, all right, something like this, tools and then calculate. All right, so something like this, let's say you have provided. So in this case, what will happen? If model selects GPT-oss, in that case, your model will be having these two particular tools. All right. But if your model is going to select this particular model, then in that case, it is going to have only this tool. All right. What you can do here, you can in fact remove these if you want. So in this case, what will happen here? This model is going to select only these tool for this one and this tool for this one. All right. Otherwise, you can keep this particular tool here common for everything, and then you can remove this. So in this way, what will happen here? that, as now you know here, that this is common for all the LLM. So this particular tool will be used for this LLM as well and this LLM as well. And this LLM is going to have one of the additional tool that is going to be the calculate. So these various ways I was trying to show you that this is many ways how you can do all these setups here. Let's go ahead and run this, and then in the runtime you can see later on. So this tool is going to be available for this one and this one as well. And this tool is only specific to GPT-oss model. Let's go ahead and select with the simplest query. So I write hello there. In this case, it knows that it is going to select only the simplest model. So we execute this. All right. Here it says that model selection. It takes the tool. Let me just see quickly. Okay, so what happened here, actually, when you create an agent and you pass this dynamic model instance here, so it is also going to accept the runtime as well. So this is something which I also have to provide here. All right, so what I do here from Langchain dot runtime, I guess it is. I guess it's a lang graph actually. So you get it from the lang graph dot runtime, and then import runtime. Let's go ahead and execute this. And although we will not use this runtime, but this particular dynamic model selection method needs this runtime. All right, just to make sure that your code works. Let's go ahead and execute this, and thereafter we execute this. So the total number of messages, only one, character 11, and the keyword, so there is no complex keyword which we have provided here, so it says that it is a false. So all these things we have tested here, and then it says that simple query processed, and we have selected the Queen 3 model. Just to verify that, you can come here at the Langsmith. In the Langsmith, you can watch the latest trace here. So this was our latest trace. There we had asked the question, hello there. In that you will notice we are using the Queen 3 model for one of the simplest query. All right, so the Queen 3 model was used here. Let's go ahead and test it with the complex query. So with the complex, I need a comprehensive analysis and detailed research on AI strategy. All right, now you will notice here that it is going to use here GPT-oss model. Let's go ahead and execute this and then see what happened here. So as you see, one message, 68 character, all these are false to select the Queen 3 model, but this particular thing is true. That means it is going to select the GPT-oss model automatically based on the complex query here. All right, thereafter you will notice here complex query triggered, GPT-oss is selected. As you come here, then you will notice here you have your lang graph, and then this is your message, and as you see here that GPT-oss model is actually selected here. All right, so your GPT-oss model has been selected. I need a comprehensive analysis and detailed research on strategy, all these things. As you see, everything is done here. All right, perfect. So this is how you can select the complex model. All right. Thereafter, what I do here, I come here, long content, GPT-oss. Let's provide the long content, really long content. So this long message is going to be really quite long, basically. You see here, it's going to be really quite long. All right. So basically, the number of total character will go beyond 3000. So in that case, let's go ahead and see what happened here. So you have like this, and let's go ahead and execute this. So you have GPT-oss 3040 character, keyword is false. So this particular thing is true. So it is going to trigger here the GPT-oss model. If you check this tracing here at the Langsmith, you can see the GPT-oss model is selected here. So the congratulations, you have implemented a system similar to the GPT-5 where they smartly select a particular model based on the user query complexity so that they can provide the fast and the accurate response. So similar to that, we have implemented in this particular lesson. So that's all I wanted to cover in this particular lesson, and I hope that you have liked this video. And also, if you have really liked this video, please like this video and also subscribe this channel. Thank you so much. Bye bye. Take care.